Hey, my name is Chris. I've been learning Rust the last few months, and as a JavaScript dev, I wanted to give you some steps that have helped me as I started picking up the language. We're going to do this in 3 stages. First of all, I want to show you one of the early projects I wrote. We'll go through several different iterations I went through so you can kind of learn some of the things that might trip you up if you're a JavaScript developer. Secondly, I want to point out a couple of open source libraries that'll be really helpful for you as you're trying to pick up the language. Looking at somebody else's code, especially vetted code, is really important. And finally, I'll talk with a real software engineer who writes Rust every single day to get his tips for how to pick up the language. You ready? Let's jump in. When I first started learning Rust, I worked through the official Rust book. At the end of lots of the modules, they'll actually give you projects that help you practice the skills you're learning. One of the first projects I built was a little temperature converter that would take Fahrenheit to Celsius and vice versa. We're going to start by just capturing a hard-coded variable for the input type we want. Now notice that I've actually given this an explicit type of F32, saying it's a floating point type because we're going to be doing some math that will return to us some decimal value. We're going to be converting from Celsius to Fahrenheit to start with. So I'm going to name a function with the fn keyword. We'll call it convertTemp, and I'm going to do 2 things here. First of all, I have this parameter named temp, and that is going to be typed as an F32. That's what I'm getting in down here. Secondly, it's going to be returning this F32. The next thing we're going to do is have this conversion. Notice that it does not have a semicolon at the end, and that's because in Rust, this will automatically return that value for us without the semicolon. Now we need to actually call this down below, so let's go ahead and capture that in a variable called convertedTemp. Notice the Rust analyzer actually added the type right here for us. That's because it can infer this from the function because it knows it's getting this back. We're saying the convertedTemp, we'll drop it in right here. Whatever we get back is this degrees in Fahrenheit. So I'll go ahead and save this, and we can just simply run cargo run, and it will run that for us and convert it to 32 degrees Fahrenheit. For that first section, we only converted from Celsius to Fahrenheit. What if we wanted to go either direction? I'm going to start by coming up to the top here and declaring an enum. This will say that we can either have the type of F or the type of C that will stand for Fahrenheit and Celsius respectively. Now, the next thing to do is to provide not only a temperature value, but also a temperature type. Now notice we're going to pick off one of these options, these enum values, and we can do this with this double colon syntax. In other words, I'm saying it has to be the type of F. I could also say it's the type of C. The next thing we need to do is actually update our function call right here, right? So let's replace this by adding in both the temp and the temp type to the function call. Now you'll notice here I'm getting a red squiggly line, and that's because it knows that up here I only have one parameter that I've typed. So what I need to do is add a second one. We'll call it temp type, and we'll assign it this type right here. Now in this case, we actually want to run a switch based off this. What are we getting in, Fahrenheit or Celsius? Now in JavaScript, you can do this with a switch statement. In Rust, you use something called the match statement. Now, unlike in JavaScript, because we know what every type of everything is, we can exhaustively handle everything with the match statement. In fact, you have to. That's the power of the match statement. Notice we're matching off the temp type that we've passed in, and we're essentially saying if it's a type of F, do this equation. If it's a type of C, do this equation. Now let's come back down this way. You'll notice that we're not going to yet update this right here. So it should just say converted to Fahrenheit, even if we're going the opposite way. For now, we're starting with Fahrenheit. Let's actually start with Celsius just so it looks correct, and then I'll switch it around. We're going to cargo run this. It will give us a warning because we're not using the type of F, even though it's up here. So that's helpful for us to know. But it does actually convert it properly for us. If we were to go the other way, so let's actually change this to 32.0, and we'll say that it's the type of Fahrenheit, and we're converting then to Celsius. You'll notice that we do that, but of course our print statement here is wrong because it just says Fahrenheit. The first thing I can do is replace this with these curly brackets, and then we'll pass in a second argument down this way. We're going to call this converted temp type. What we need to do is basically figure out the opposite of whatever they've passed in here. So once again, let's go ahead and do a little match statement. We'll match off the input temp type. If it's the type of F, then I want to return the string of Celsius. If it's the type of C, I want to return the string of Fahrenheit. Then this right here, this input temp type, is what we're going to be using down this way. And we've captured the resulting string in this converted temp type, and that's what we've passed in down here. Now notice if I actually pass this down below here, you'll notice that we should get an error. And the reason is as soon as I've passed in this input temp type, the function now owns it. This concept of ownership is really important in Rust. This means that at this point, I can no longer access it because it's no longer in scope. So I actually have to move this up above here. And that way I can do the match and store this here before it's passed off to the function where it is no longer in scope for this main function body. Let's go ahead and run it one more time. You'll see I'll still get that error because we've just hard-coded the value, but I'm actually now getting the correct return result here, which is Fahrenheit 32 degrees down to 0 degrees for Celsius. Finally, it's all right to hard-code everything, but as you might imagine, we want the user to be able to input either Fahrenheit or Celsius and get out the opposite. And let's go ahead and use the standard input-output library. Now done this way, instead of typing this manually, what we want to do is ask the user to provide it. Let's first of all, though, define a mutable variable. Here we're going to set this to the type of a string, but it's mutable, which means we can add to it or remove from it. The next thing I want to do is tell the user to actually print out a temperature value. Then we're going to take that and ensure that they've actually done that. What I'm going to do is grab this mutable variable. We're going to check that it actually exists. If it doesn't exist, we can throw this exception here where we're saying, hey, we expected something and we didn't get it. Assuming that there is something there though, now what I want to do is convert it from a string to a number. And I can do that explicitly. I have to do it explicitly in Rust. I can't just do this like in JavaScript whenever I want to by saying it's going to be the type of floating point 32. So we'll take this user input that we've gotten right here. We'll trim it to make sure there's no white space, and then we'll parse it according to this right here. If we don't get back the expected type, we can go ahead and say, hey, this doesn't work. But now we know we should have a floating point 32 where we actually get back a number, and we can use this in our function call. Then also do the same thing down here. Instead of having a hard-coded input type, instead, I can do the same thing where we declare a new string. Then we ask the user to go ahead and enter in either F or C. These correspond to the enum that we set up already. Now what we're going to do is check that something has been entered. Assuming that something has been entered, we're good. Otherwise, we can throw this message where it failed to read the input. And then finally, what we want to do is check that the string is either the capital F or capital C. So we'll take the string and we'll match it and say that we're going to trim. Then we're going to uppercase it and read it as a string and say that there's basically two options we can accept. Either F, which corresponds to this type, or C, which corresponds to this type. One of the cool things you can do is panic. So to say, hey, if this doesn't get back what I expect, go ahead and crash the program and tell them why it's been crashed. Now, the last thing to do is to update this current temp type here down this way. In other words, I want to take the actual converted value here, and that's what I want to run this off of. It's either a type of F, in which case I want the output, the new output to be Celsius, or the type of C, in which case I want it to be Fahrenheit. Now I do need to take this current temp type and make sure that this is what we're running the check off now, because it should be either F or C. Now that's also the exact same thing I want to actually pass to my function as well, the converted temp type, again, either F or C. Everything else should work just the same. So if I come over here and run cargo run again, it's going to ask me to enter a temperature value. I could say something like 32, and I can say either F or C. Let's say F, and it should convert that, and now it says 0 degrees Celsius. Now for this second section, I want to look at a few really popular open source libraries built in Rust. Looking at people's code, especially people who've been vetted, is really helpful when you're trying to learn a language. So the first tool I want to point out is something called Volta. It's a tool manager for JavaScript. It can quickly run any JavaScript tool, and it's really, really quick. And once again, it's built in Rust. If you're interested in the code, you can just check it out on GitHub and just comb through all the different code in here. You can see that we've got stuff from years and years ago, 7 years ago, all the way up iterating up until just 4 days ago right here. Now, what I would recommend for any of these is by starting with the main.rs file. This is the entry point for the program itself. Starting with just a single section, you can then look and see, okay, what exactly is happening here? You can see different libraries they pull in, different macros they're using, and as you run into issues, you'll find real solutions in actual real open source projects. The second project I want to encourage you to look at is the Starship Prompt. This is a prompt for any shell, and again, it is built in Rust. That's why, of course, it says blazingly fast. Once again, you can check this out on GitHub. And again, you can start by looking at the SRC folder and come inside here and find the main.rs file. Now, obviously, this is a little bit different. It's actually using a library called clap. And this tool is meant to help you write command line applications. So if that's something that you might be doing like we did in our last project, you may want to use something like this to figure out how to actually get inputs and how to use them with clap. That might be actually an iteration you could do on the project I just shared with you. Once again, you can comb through the code yourself and actually see how they're using Rust in real life. Here we have an enum similar to the one we created, obviously a lot more complex, and it points to different structures or essentially objects that it's referencing, so shaping of the data. Now, because it's for use with macOS and Windows, you can see they're actually doing some Windows configuration here as well. So if that's something you may want to do, then that's a great starting point for you. Just like we saw in our very simple program, there are times where things are going to be okay, and there are times where you'll actually throw an error. This is a great opportunity to see how something like that would be done in real life. And here we find that not only are they using the standard library to read data, they're actually using it to write data as well. These are just two of many, many projects that you can look at in the open source community that give you a better sense of how something is actually written in Rust in real life. Finally, I want to talk to an engineer friend of mine named Advait, who writes in Rust every single day.
Advait, thanks so much for meeting today. I really appreciate it.
Yeah, for sure. Love to chat.
I'm going to focus primarily on education. How did he learn, and what are some suggestions that he has if you want to learn Rust today?
So I hadn't done Rust actually before coming to Warp. I was definitely, I guess, a bit nervous, but also excited kind of going into this role of like not having done Rust before. My approach to Rust was largely like trying to map it back to prior concepts I'd learned in different languages, and then understanding like the parts of Rust that make it unique. I can map back to XYZ concept in like Python, Java, whatever else, C++ and stuff. And then these are the new things that are like specific to Rust.
Advait used his previous understanding from other programming languages to pick up key differences when learning Rust. But what were these key differences, and why were they hard to learn?
Two concepts that really tripped me up were, number one was kind of understanding how borrowing works, and kind of related to that is ownership and references. Number two is kind of understanding how the concept of lifetimes works. I think those are the two things where Rust has this very unique kind of model of managing memory, and it's part of the reason why Rust is so powerful, but it also is just really difficult to wrap your head around if you're like coming from like, let's say a garbage collected language like Java, or some language where you're manually managing the memory like C or C++.
Yeah, well, I totally agree with that. That's been the weirdest thing.
Going from automatic memory management to Rust's ownership model can be really difficult at first, but it is what people love most about Rust. So I asked Advait next, what are some learning resources he would recommend for picking up Rust?
There's the official Rust book. There's Rustling exercises on GitHub where you can try out these exercises. Actually, a site called Rust by Example. That's great. You can actually run code in the browser. I do have a physical book by Jim Blandley. I believe it's published by O'Reilly, and it's a great book that goes through more details of like how to use Rust in a like systems programming context. There's some article on common Rust lifetime misconceptions, and so if you Google that, I should be able to find it. And there's a lot of like common things that people get wrong when understanding lifetimes, for example.
Thanks again. I really appreciate it. And
yeah, for sure. Love to chat.
If you're learning Rust today, I hope these 3 steps were a big help to you. If you're interested in more Rust tutorials, please let us know. Thanks so much for watching. I'll catch you in the next one. Happy coding.